Hi, in this lesson we're going to be looking at the intersection of a line and a plane. Here we see we've got a plane and we've got a line that's passing through that plane, and right there is where the line and the plane intersect each other. We're looking for the position vector of that point now. So we've got an example here. We're going to try and find the position vector of the point of intersection of this line here that's been described parametrically, and this plane here that's been described by its Cartesian equation. To get us started, just to give us a sense of what's going on, I'm going to plot this on autograph. So we're going to see what this looks like geometrically before we start. So we will start by putting in the equation of the plane, and that is 5x plus 3y take away 2z is equal to 22. Okay, so that's what our plane looks like. We're now going to find where the line intersects that plane. So I'm going to put in the vector equation of the line. Just pop this down here. So we've got 3, 1, 5, and negative 3, 4, 2. Okay, and if I zoom out a little bit, and we should see, or not. Oh, okay, so we should see that there is a point that the line goes through the plane, and that's the point that we're looking for. So we're going to have a look at doing this algebraically. Okay, so what I'm going to start off by doing is writing this. This is our general point R, that's equal to our position vector plus lambda times by our direction vector. I'm going to write this as a single vector here, and I'm going to write this in terms of x, y and z. So we're going to have x, y, z, and that's equal to, and that's going to be 3 take away 3 lambda 1 plus 4 lambda and 5 plus 2 lambda. Okay, so our x component is equal to that there, our y component is equal to that, and our z component is equal to that. Okay, so because I know that from my Cartesian equation that 5 times my x coordinate plus 3 times my y coordinate take away 2 times my z coordinate on this plane is always going to be equal to 22, and I've got my x, y and z in terms of lambda, I should be able to substitute this into here to work out which specific value of lambda is going to make this the same as this. So I'm going to have 5 times 3 lambda plus 4 lambda take away 2 times 5 plus 2 lambda equals 22. And if I expand this and simplify it, that's going to be 15, 18, 8, let's take away 3 and take away 7, and that is equal to 22, which means that lambda is going to be equal to negative 2. There we go. Right, so we now know what value our parameter needs to take in order to make this true, so I could substitute that into here to work out what my position vector is going to be. So I can say that my position vector where the intersection takes place is going to be, and I'll stick it into here, so that's going to be 3 plus 6, which is 9, 1 take away 8, which is -7, and 5 take away 4, which is 1. And now I'm going to pop over to autograph and just check that our solution is actually 9, -7, 1, and I am going to I'm going to select the line and select the plane. I'm going to ask autograph to find our point of intersection, and it tells us down here that our intersection is in fact 9, -7, 1. And there's our intersection point there, 9, -7, 1. Just a quick recap on what we did then. We took our parametric form of the equation of the line, and we decided that what our x, y and z component of this was. We then substituted our x, y and z component into the equation of our plane, so that we could work out what this parameter would be in order for this to be equal to 22. Once we knew what the parameter was, we substituted our parameter into our vector equation to find out what specific point our point of intersection was going to be, and we worked out that was true. Thanks for joining me, and I'll see you next time.